So, hi guys. So, today in our today's session, we will be discussing the most important questions of permutation. Okay, not combination, just the permutation. So, we can see the first question, which has been asked repeatedly in a lot of exams, which comes in the exercise of permutation 7.3, ninth question. How many words with or without meaning can be made from the letters of the word Monday, assuming that no letter is repeated? So, if the condition is given, if there is any restriction, okay, you should not do that, or that particular command is there, then we have to use what? Permutation. If there is no particular instruction or there is no command or nothing, it's our own choice, means it's combination. So first thing is to identify the question. We identify the question as what? Permutation. Correct. And what is the first question? How many words with or without meaning can be made from the letters of the word Monday, assuming that no letter is repeating, which means I cannot use M again because no letter can be repeated. Correct? If it is used once, that's it. MONDYA also I can put, but I can't put DYY. So that is the thing. Now, first condition is assuming no letter is repeated if 4 letters are used at a time. At a time, how many letters I should use? 4 letters. Correct? 4 letters I should be using at a time. Correct? So what is the number of different words that can be formed? So first step is, what is the total number of alphabets in Monday? 6. And what is the condition given? The 4 letters are used at a time. That is 6P4, NPR. Correct? NPR is what? N factorial by N minus R factorial. That is 6 factorial by 6 minus 4 factorial. That is 6 factorial by 2 factorial respectively. So 6 factorial is 6 into 5 into 4 into 3 into 2 by 2 factorial. That's it. So NPR basic formula we have to know in this. There is nothing but what? N factorial by N minus R factorial. So according to your condition. So R is nothing but the condition which is given. So that is about our first thing. So this they can ask for 5 marker. Okay, so this they can ask for 5 marker. So that's the reason I'm going to discuss this question first. Okay. So first thing is over. And now let's take the next one. So this is over. How many words, same thing, with or without meaning can be made from the letters of the word Monday, assuming that no letter is repeated if all letters are used at the same time? All letters means what? All the 6 letters are used. So all the 6 letters in the sense 6P6. Correct? So 6 factorial by 6 minus 6 the whole factorial. So 6 factorial is what? 720. 5 factorial is 120. 6 factorial is 720. So 720 by 0 factorial. That is 0 factorial is 1. 6P6. Number of different words. That's it. It's a very simple question. Next question. All letters are used, but first letter is a vowel. The condition here is what? How many words can be formed with or without meaning of the word letter Monday? But all letters are used, but the first letter is what? Vowel. Correct? So we know what is vowel. A, I, O, use a vowel. In Monday, how many vowels are there? O and A. But first letter should be what? Vowel. Correct? Yes. So assuming that our first letter is a vowel, the word will start with what? O. Monday totally how many are there? Monday totally 6 are there. Correct? But in Monday, how many vowels are there? O and A are vowel. So number of letters I can fill is 5. So any of the 5 letters I can fill. That is basically 5P5, 5 factorial. If it is 5P5, it is 5 factorial. That's it. That is 120. Correct? Then similarly, if the first letter is A also, it is 120. So that's the thing. So next question. So I think this is clear. So, but if you got any doubts, once the class is over, I'll help you out with it. In how many ways the letters of the word permutation can be arranged if the word will start with P and end with S? So P and S. So the positions are fixed. Correct? If the positions are fixed, first thing is what? How many letters are there? Totally there are 10 letters with how many T? 2T respectively. Correct? With 2T. So I'll write down here, then I think it will be easy. Permutation totally 10 letters are there with 2T's fixed. Totally 2T's. Then what formula we have to use? N factorial by what? P1 factorial. The letters which are been repeated. So here it is what? 10 n factorial is 10 factorial by n factorial by 2 factorial because of the T's. That's all. I'll scroll down for better understanding. So since the letters are repeating, correct? N factorial, 10 factorial totally. Correct? By 2T, that is it. 2 factorial. We get this number. Clear up to this? Second question is, how many ways the letters of the word permutation can be arranged if the vowels are all together? Correct? So in permutation, we have to identify what the vowels. And the vowel should be together. So this E, U, A, I, O should be what? Together or taken as a single object. Yes? Correct? Then remaining letters, I am fixing it in a box. Yes or no? Yes? Remaining letters I am fixing it as a box. So here how many are there? How many letters are there? 5 letters are there. So if the vowels are coming together, the same thing what we used in the previous question, it is different. 5 factorial. 5p, 5. Correct? 5 factorial. 5 factorial is what? 120. Now how many other letters are there? 1, 2, 3, 4, 5, 6, 7. So this 7 I will take it as a 1 unit plus this one. EAU, EAU, IO, I'll take it as a 1 unit. 7 plus 1, 8 totally. Correct? And again in this 8, there are 2 T's which are repeating. So 8 factorial by 2 factorial. This one already I told you, it is 5 factorial for the vowels. That's all. So once you do this, you will get the arrangements easily. Next question. In how many ways the letters of the word permutation can be arranged if there are always 4 letters between P and S? 4 letters between what? P and S. Permutation. Correct? Yes. So we know totally what PERMUTATIONS. So they're totally 12. And position of P and S are fixed. Correct? P and S. 4 letters between P and S. But here, unlike the previous thing, in how many ways letters in the word permutation can be arranged if there are always 4 P letters. But here the P and S, unlike the first question, are not fixed. I just want to clear it right away. The P and S are not fixed just like that. We can arrange it in any ways, but there should be what? Always 4 letters between P and S. So, considering the position of P and S, P can be what? In the first. Correct? And there should be a 4 gap. Yes, there are always 4 letters. Second, third, fourth, and fifth. So 4 letters. So 2 and 7, 3 and 8, and 7 and 12, but 8 and 13 because there are only 12 digits. That's the thing. So totally how many cases are there? 7. When there are 4 digits between P and S. So total cases how much? I can do the reverse. So it will be 14 cases. S and P can be interchanged. So it will be totally 14 cases. Correct? So in the first case, if I want to find position of P and S are fixed. If I'm fixing it in the first case, P and S are fixed. We need to arrange this remaining letters where 2 T's are there. So n factorial and P factorial, P1 factorial. But here there is only one alphabet is repeating. It's by 2 factorial. So what is my n factorial? Count the remaining letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 factorial by 2 factorial. So total arrangement should be what? There are 14 cases totally. First case is with fixing between P and S, and similarly second case is what? S and P, just vice versa, S and P. So 14 into 10 factorial by 2 factorial, we'll get it. So I hope it's clear. So again, this is one of our rather famous question. Mississippi. In how many of the distinct permutations of the letters in Mississippi do the 4 I's does not come together? Mississippi has already got how many I's? The alphabet I, 4. Correct? So we have to do what? Total permutation we have to do minus I not coming together. I not coming together. Okay, so we have to know in Mississippi how many I's are there. 4 I is there, 4 S is there, 2 P and 1 M. So since the letters are repeating n factorial by, we'll use this formula P1, P2 and P3. Correct. Total number of alphabets is how much? 11 are there. So 11 factorial by repeating. So 4 factorial, 4 factorial and 2 factorial we have to do. We'll get one answer. Correct. Now total permutation of the I coming together. The rest of things I'm arranging and I as a single unit. I as a single unit. Correct. Now the remaining letters are what? 4S, 2P, 1M and what? I as a single unit. So remaining 4 plus 2, 6, 6 plus 1 plus this single unit. Totally 8 are there. So 8 factorial. By how many S is repeating? 4S is repeating. So 4 factorial. And how many P? 2 factorial. And how many M? 1 factorial. And I is also 1. So that's the reason I'm not writing down those things below. And then I'll subtract 840 from the previous answer which I got. Total number of permutation. So these are the important questions in permutations. Okay. So I hope it's clear for everyone. And if you got any doubts, I'll be very happy to help you out. So thank you.